What I'd like you to get out of what we've done so far is that these two bits, the subnet bits that we took, determine the new network IDs. So therefore, we could generalize this into a formula. 2 to the power of s, s being the number of subnet bits, will determine how many different subnets we get. So in this example, we took 2. 2 to the power of 2 equals 4 subnets. Remember the formula we looked at a while back for calculating the number of IP addresses? Do you remember what it was? It was 2 to the power of 32 minus the prefix length minus 2. That gave us the number of IP addresses we got for a given network ID. In this case, applying that, it would be 2 to the power of 32 minus 18 minus 2. Let's use the calculator here. 2 to the power of 32 minus 18 is 14, equals that, minus 2 is 16,382. 16,382. If we took 2 bits, made it part of network ID, we get 4 subnets, each of which giving us 16,382 IPs. Suppose we took another bit. Suppose instead of taking 2 bits, we took 3. How many subnets would we get? Think about that for a second. Well, it's 2 to the power of 3, which is 8 subnets. To take that extra bit, I would need a prefix of /19. Therefore, the number of IP addresses I would have is 2 to the power of 32 minus 19 minus 2. This is going to work out to 2 to the power of 13. 32 minus 19 is 13, which is equal to this, minus 2, which is 8,190. What I'd like you to get from this little discourse is that to calculate how many subnets you will get, it's 2 to the power of s. We're not minusing anything from this. The old formula for calculating IP addresses is 2 to the power of 32 minus the prefix length minus 2. If it is that I took 2 bits, for network ID I get 4 subnets, 2 to the 2 is 4, and that gives me this many IP addresses left over. If I took an extra bit for network ID, I double the number of subnets I get, but I half the number of IPs that I get. And this is a trend that you will see. If we had taken 8 bits, I would get 16 subnets, but I would only get about 4,000 IPs. So the more bits that you take from host ID for network ID increases the number of subnets you get by doubling, but it cuts the number of IPs that you get per subnet in half. This actually makes a heck of a lot of sense if you remember the diagram I showed you in the previous video. Here we are looking at that number range again. For the network ID 172.16, we went from 172.16.0.0 to 172.16.255.255. If we took 2 bits from host ID and made it part of network ID, we got 4 subnets. It evenly divided the range into 4 pieces. If we were to take an extra bit, what that would do is that would divide the range into 8s, and it would half the number of IP addresses that we get per subnet, because we're taking something that would have otherwise been divided into quarters, and we're dividing it into 8s.